Good morning, or good afternoon, or good evening. Welcome to Advent of Code Day 3. It is 6 o'clock in the morning and we are ready to go. Day 3 crossed wires. Let's see, I'm going a little bit more quick than I did last time. The fuel management system wasn't completely installed. Jumble of wires. Two wires are connected to a central port and extend outward on a grid. You trace the path each wire takes as it leaves the central port. One wire per line of text. Your puzzle input. Okay, let's download the input. And see what that looks like. Oh, so I guess it goes right 999 times, up, so on. Yeah. Okay. The wires twist and turn, but the two wires occasionally cross paths. To fix the circuit, you need to find the intersection point closest to the central point. Because the wires are on a grid, use the Manhattan distance for this measurement. Well, the wires do technically cross right at the center point. This doesn't count, nor does it count when a wire crosses itself. Okay. For example, if the wire's path is blah 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 blah, then okay, these wires cross at two locations. See? The lower left one is closer to the central point. What is the Manhattan distance from the central point to the closest intersection? Okay, well, I think we can do that. Opening the input, read lines, trim for line in. Okay, so here are the lines. And I promised myself to write a class for the first time. And I'll call it wire intersector. Yeah, here you see I already am going for abstractions too quickly. I don't know yet what I'm even going to do. I'm going to loop over the lines, aligning lines. Steps. Double loop. And step distance is the rest. We are going to keep a grid of all the lines. That's right. And let's give each line, each wire a name also. Oh yeah, it's called strip. Many values to unpack. How do you iterate again? with an index. Stupid and simple. Yeah, Python. Hey, I did search for Python. Enumerate. Okay, so this part is correct so far. Now we're going to draw on the grid. Position for each line starts at the starting point. Is it really 0, 0 where we're starting? The central port. I guess there is no absolute grid. Everything is relative. So we can just consider the center point 0, 0. Well. So we actually need to calculate the target position and iterate from the current position to the target position. Let's call it step target X and step target Y. Need to calculate those. So we have up, down, and right and left. So if we go up, we go minus the distance. We go down, we go plus the distance. We go to the left. And otherwise we go to the right. These are not defined. I will first make a variable called dx and yx. So these are the distances that we're going to travel. Ty equals x plus dx plus dy. I see I didn't name that one correct. So Tx will be our target. Now we're going to have to loop over everything. We're only going one direction at a time. So the distance we can just loop between 0 and the distance. Let's call it steps are a little bit confusing now because we're talking about movements, motions, and a single pixel, moving a single pixel is also a step. And now I'm going to get confused. Let's call them section. Okay. I'm going to loop. I'm going to parse that as an integer also. at every step of the way we're going to go from x and then add, let's see, perhaps I'm just going to use 1, 1, 1 and 1. Y is y. Like this, x and y. Now I think we should have the logic done, and now we need to save it into the grid. It's a grid that has dictionaries in it by default, and X is also a dictionary, and I want to be able to store all the line numbers in there. So this is also going to be a default dictionary. Turning on soft wrapping. Oh, you know what? I can actually make it into a... No, I won't make it into a list. Because if a line intersects with itself, it's not actually a thing that we're looking for. It's expecting a dict. Default dictionary with no value. Be like this. So let's start with a simple example, such as this one. Yeah. Okay. Now we're supposed to be able to run this. We cannot support item assignment in this line. But I think this really should have been a dictionary, but my editor is complaining about it. Okay, finally got 3. After a little bit of time, we go all the way to the right. Let's follow listing. Am I printing? I'm printing something here. Where is that? Printing sections. I would like to print the section. Then we go up 5, but our X position is lost. And that's because we are resetting our X and Y. Which is correct. For every line we need to start at 0, 0. Alright. This is only one line. This is actually our input. We went right, then we went up, then we went left, and then finally 3 steps down. Okay. And then you add a second line. Second line ends in 2, 2. We see 2 minus 2, is that correct? Or 2 to the right and 3 up. Okay, and now we need to know where they intersect, and that will be easy since we have a grid of intersections. And we need to find the one that's closest to the center. For rows in grid columns. Let's see. Just to get it right, at every position we now have a list of crossings. Yep. So if we have more than one, we have an intersection. And then we're going to write it down. We only need to know the nearest one, not the one with the most intersections. In X and in Y. So if we didn't have an intersection yet, or the minimum intersection that we had is bigger than the intersection position we're at now, then min X is going to be X, and min Y is going to be Y. Also for the case that Y is actually flip these. If Y is smaller than the minimum Y we found so far. And then we're going to print it. And we still need to disable this little checker. Okay, that should be our answer. And then the Manhattan distance will be the absolute of both of them. Let's see, the Manhattan distance is the sum of them. Yeah. So it would be 11 for the example here. The central distance is 3 plus 3. So we have a bug. doesn't work. So we have one at 3 and 3. We need to compare with the absolute, because negative values are not more close to the center. There we go. Now I'm confident to run it on the real input and see if it is right. Wow, a lot of steps. It is not the right answer. I guessed this one, so I'm writing down the ones I guessed. Please wait 1 minute to try again. So I tested again on some other inputs. See? I think I just messed something up. Okay. Here we are. Our distance should now be 195, and it's not. Let's also print the Manhattan distance for each of them. So the minimum distance, the distance is these two. That means we can calculate it a little bit easier also. Like that. We're going to print minimum. We're going to print min x and y and the minimum distance. Yeah, it's not correct in this case, so let's see where it went wrong. It would be helpful actually to be able to print this grid. So let's do that. Yeah, but of course we are going to also have to print positions where there isn't any intersection. That is a bit tricky. So right now, let's see how I'm gonna do that. Left bound, right bound, free bound, and bottom bound. Do I really want to render a grid right now? No, I don't. I want to get this done quickly. We end up in the right spot. So in this example, I remember we did it right. I do want to try it again though. Ah, we don't actually get it right. Ah, I did this the wrong way around. Yeah, now it's right. Okay, let's do it again. Yep. Oh. Oops. Full input, please. 399. That's correct. Right. Right. That was alright. I'm going to commit this and then do the second one. Well, so far it's going alright. It took 26 minutes. I think it's a bit slow. Yeah. The basics were done quickly, but then getting the final answer is always the thing that takes the longest time. Part 2. It turns out that the circuit is very timing sensitive. You actually need to minimize the signal delay. To do this, calculate the number of steps each wire takes to reach each intersection. Choose the intersection where the sum of both wires' steps is lowest. Choose the intersection where the sum of both wires' steps is lowest. So we don't care about the nearest one to the center, but the one that's reached first, if you consider the steps as taking time. Now here, steps of course is the most important term here. What is the step? They haven't used the word step in the first section of the puzzle, and so I just want to make sure that they're using this step as the same in the same way as I do. Okay. If a wire visits a position on the grid multiple times, use the steps value from the first time it visits that position when calculating the total value of a specific intersection. So that means that wires can kind of cheat. If they intersect with themselves, they can just take a shortcut and they kind of short circuit. The number of steps a wire takes is the total number of grid squares the wire has entered to get to that location. The intersection closest to the central point is reached after 855 plus 2 is 20 steps. They don't mention which location that is, but I'm assuming it's this one. Yeah, okay, the top right intersection is better, right. What's the fewest combined steps the wires must take to reach an intersection? So what's the earliest reached intersection? So what I need to do for that is for each intersection to keep how much time it took to reach that point for every wire. Okay, so instead of true and false, I'm going to have to keep a list of steps. So that is quite easy. Instead of true, I'm just gonna write down the total number of steps. Unless that already existed. I think I should write it like this. I've done a little bit too much SQL. Total number of steps for the line is 0 when we start walking, and then we add one for each. Basically that's it. I'm gonna try it. See if we can get the right answer straight away. So if we have more than one item, then let's see, the total number. We need to add all those timings from each wire, don't we? It's a total of 20 steps. It doesn't really make sense to add them though, logically speaking, because it's not like if 2 wires need to reach it, it takes double the time. Yeah, so we do add them actually. So the min time is none. So the time will actually come from, it's the sum of all those lines. If the time is less than the minimum time we've seen so far, then we're going to keep the minimum time. That's it. And minimum time, we can print it also. That means that the minimum distance is no longer needed. I'm going to remove that. Means day 1 is no longer available for running. Okay, let's just go with this and see if it works. It's correct. Nice, awesome. Very lucky I didn't even test it on the examples. Alright, there we go. That was 33 minutes in total. I still haven't figured out how to see my global rank. If someone could point out to me how that works, that would be great. I see here some numbers, but it looks like that means the number of people who have completed that particular puzzle and not my rank on it. And on the leaderboard you can only see the top 100 of people. And I'm not on it, most likely, I am assuming. No. So I have no idea. Personal stats. Ah, there it is. Let's have a look. So I was ranked 619 for part 2. Yeah, I think I was really quick on part 2. Took me only a few minutes, but because the first part was quite slow, that means that we're still not going to end up in the nearest 100 or few hundred. And only the first 100 people get points. Did I get that right? Yeah, 0 otherwise, so I have 0 points so far. That's too bad, but I'm having a lot of fun. And I'm happy also that I got this second part solved very quickly. So something interesting just happened during this puzzle. Yesterday I was writing all my code like I was doing today, but I got confused because I'm using globals everywhere, and when I extracted some stuff into methods, it became very messy. And so my plan kind of for today was to start using classes straight from the beginning, but from the moment I started typing class, I just removed it right now. I had class up here. From the moment I typed class into my editor, I realized I have no idea what this class is going to do. I don't know yet what the steps are. I know that I'm going to have to loop over those lines and then process them and keep some state, but I don't know yet. So, you know, when you make a class and you're gonna add a method, you need to give that a name. And I guess you could start by just saying foobar. Maybe that's the right way to do it. Just call the method foobar and call it. And then if you are going to split your code up into different sections, then you can give those methods specific names. But you're still going to isolate all your variables in those sections from other sections. I'm talking about methods here. So here I have access to all my variables. If I decide that this should be a method, you know, suddenly the dx and dy are no longer going to be available. I'm going to have to return them and pass them back. And then maybe I do need, yeah, you know, you might have reached some kind of conclusion or some kind of state that you want to reuse, but now it's inside a method and you can't access it anymore. You're going to have to refactor things. I feel like for these kind of exercises, object-oriented programming, in the sense that you write everything in objects, might actually slow you down a lot. Well, at this point, you know, when you're done, when you know what you're building, I think at that point you can refactor into classes. That makes sense, because yeah, this is one big, you know, one big mess of code, and it's not too long. It's 60 lines, so it's not terrible, but you have no idea what each step is doing. This is a big loop, this is a loop, this is a loop, like 3 nested loops. That's not what we tend to do. We tend to like make a method for every loop so it's clear what that loop is doing. So, you know, this could be like, this stuff is processing one line, and not to say a line of the file, but a wire, kind of. But this is processing a wire. And here we're processing a section of the wire, and here we're processing a step of a section. So you could extract that into methods quite well. In fact, I'm going to do that. I'm going to commit first. And also I'm a little bit sad to not have part 1 into this. I did solve part 1, of course, but now you can no longer see the output. So to keep a record of how I did that, I'm going to output part 1 as well. I'm just going to make 2 separate loops for that. And now I guess I can easily put this into a method. And let's see what IntelliJ, or rather PyCharm, makes of this. Part 2. So you see, it is going to use globals. This is the PyCharm's favorite way of making methods. And I guess that's because I didn't include those variables in the method body. I'm going to try it again. Part 2. And we still have some globals. And maybe that's because I'm printing here. Oh man. Why can't it just return some out, like some variables? Pass them out. Part 2. Okay, now we still have only y and x, which is funny because they are actually local variables in this case. PyCharm has no clue. And the line times, that is also a local variable. I have no idea why PyCharm makes that global. Ah! How did this happen? Did I rename that one? Line times? I guess I renamed that one at some point and then I just renamed it everywhere. Also in other parts of the code where it had a different meaning. So now we have a distance and we can see that we're not using it, which is correct. Let's see if we can still actually get the output. Let's look at my answer. Day 3. My answer was this. We still have the right answer here. Okay, so that's part 2, and part 1 is almost the same. I'm going to see if I can actually get it out of my history. Would be nice. So here's part 1. Maybe we can view it. Compare with local. Here we go. This is the section that calculates the nearest intersection. Like that. With the minimum distance. Yep. Part 1 and part 2. Let's run it again. And the first answer was 399. Yep. So now we got it refactored into separate methods. I'm going to commit this. Combine part 1 and 2. By the way, I guess this is the time to announce that if anyone is stuck on their puzzle on day 3, I'm very happy to help you and solve your bugs. Just come on the chat, share your code on Pastebin or wherever, and we'll have a look at it together. I know a bunch of languages, and usually I'm able to figure out what's going on. Most likely, if it's a language I don't know, you're more advanced than me, and you probably already solved it. But we can look at Ruby, Java, Kotlin, Python, obviously, PHP, JavaScript, TypeScript. That really doesn't matter a lot. Most languages have a similar syntax or an understandable syntax anyway. Then we can see if there are any bugs in your code. And so for now, I'll just refactor this into a little class. And I'm going to call it intersector. I like the name. And this will be called foobar, as by my own suggestion a little bit earlier. Why? Because I don't know what this class is going to do. Intersector is a real word. I made it. So let's save it. Then we need to have an initializer. Implement methods. Nope. Init. And the grid is going to be in there. Man, I like loosely typed languages, but I don't like not being able to define properties on classes. I would so much rather have written it like this, but it's not possible. Foobar may be static. Yeah, that's correct. Okay, so our grid here is going to have to be referenced like this. And part 1 and 2 are going to be inside the class. In Python, that's easy to do. Just one indent. One little indent is all it takes. Right. Intersector part 1 and 2. That. Yeah, expecting blank lines, who cares? we still run it? Not really. And that's why. Why is that? We have all the lines here. We're not calling foobar. Let's call this function solve and run it also. I guess most puzzles are going to have a solve function in it in the end. Right? I'm not so much insistent on small commits, but for now I'm going to do that. And what is nice, of course, is if we could load different inputs into the solver. Well, do I really care? Yeah, I do care that this is a global. It's not nice. Let's just pass in the lines from outside. But this is the way like a file should look. Just a class at the top. And then in Python we have something a little extra. We have something like if name is main, what was it? So we're solving with those lines. And let's run it again. We still have input, output I mean. Shadows name line from out of scope. Yeah, so what I like to do to solve that is to not write any code in global scope. The way to do that is to create a function that is called main and writing everything in there. And then just calling main like that. Now you have no global scope and we should not get any naming conflicts. Here we go. Starting to get a bit cleaner. Removed globals. So IntelliJ is not very happy to let me commit this thing. I have to click it many times. Maybe that's because I'm streaming and there's a bit of input delay. Scrolling is also a little bit more slow than usual. I noticed that the target X and Y are not used at all. It's because I'm just incrementing it as we go, in line, so to speak. And this little helping function here is completely incorrect. That's bothering me a little bit. Can we add a type hint? We can, apparently. So it's a default dict going from any to integer. Does it work now? Yeah, now it does actually give a correct highlight, no errors. Quite alright. The last one is int to int, which means line index. Nope. We do it like this. And this is the step count. Yeah, I'm going to call it wire index. Like that. So this whole thing is just a type hint. It's a little bit ugly, I must say, to add all this stuff into the code. But the advantage is that those type hints are kind of separate from the rest of the code. In Java or Kotlin, for example, all your type declarations are inline. So that means that when you're writing something like this, Well, in the case of Kotlin, you wouldn't have a lot of extra type hints because, yeah, except here you would have some kind of a generic type like int to int when you made a map. But in a lot of places where you declare variables, you're going to have like a generic types explicitly specified, or you're going to have types annotated in other ways, and it makes your code a little bit more verbose and actually less easy to read, in my opinion. It makes it easier to see what the types are, but conceptually, if you just want to know what's going on, what are the operations you're doing, then I think all the type stuff is going to be noise. So that's an advantage of having your type separately. And yeah, the same advantage you might get in TypeScript, where you can actually put all your type definitions in separate files. So where are we? We are still able to run? No, we are not. And that is because I added the type definition. Is that the reason? Yeah. And what if I don't have a type definition? I can run it. And here was any before, and I changed it into int. I've never worked with type definitions before, and so I'm a little bit surprised that this doesn't work out of the box. We have a grid, which is a dictionary of rows. This is the row index kind of column index. Within it, for every wire, a number of steps. And that doesn't work. So, okay, no type definitions for now then. Still want to keep a bit of pace. So, these are lines because they are text. But once we are processing them, they are going to be wires. And after we read the sections, then yeah, we don't actually need to store any wire in a variable. That simple. And here we could say like process section or process wire. Yeah, I guess we could process a single wire. Like this. Although, of course, the term process is an anti-pattern. You usually don't want to have the name process in your methods because processing is so generic, it can mean anything. And that's why it's also one of the most popular names. So what we're actually doing when we're processing in a wire, we're actually laying it out onto the grid. So maybe we should call it trace wire. Here we're going to call it trace wires. And apparently the wire index is passed along. That's fine. So what I noticed now is that when you do method extraction in a class, inside a class, PyCharm does correctly use parameters and not globals. So it does make it a little bit easier to work with your code. So we have part 1, I'll collapse it in part 2, and this is the trace wire code. Yeah, this is the sort of thing that we're gonna reuse over and over in Advent of Code. It would be cool if we could rewrite that into something simple that I can just type again and again. So that's going to be my challenge for right now. Method names, commit. So yeah, basically for every direction we have a certain dx and dy. So you could also do something like directions equals a dictionary. And now we need to do it like this. So it's x and -1. It feels a little bit less explicit than what we had here. This is very explicit. This is not explicit. Here we said that we're talking about a direction, and when it's up or u, then the dy is going to be -1. Now, all these equal signs, of course, are not necessary because, because we're not really reusing that. So this would work also. Yeah, if I look at it, then this notation is, of course, more simple. Is it shorter also? So down means 0 to the side and +1 down. Left, right. So left is -1 and right is +1. And then section dx dy would be directions, then the current direction, and then we could actually like extract both of them at the same time, like this. So either here we have 6 line breaks, and here we have 7 line breaks. Now, which one do you think is more easy to read? Or more easy to expand, or more easy to maintain? I did forget, however, that this should be included in our line count. So now we have 9 as opposed to 6. Well, that sounds like a big difference. You know, that means that you can see 2 methods on the screen instead of 1, for example. It does make a difference. And of course, if we wanted, we could make dictionaries of this, but that makes it a little bit less handy to work with. I guess what it comes down to is that in Python we don't have a switch statement. And if we did have a switch statement, it would definitely be easier to just use that. Python 3 switch statement. How to implement it in Python. Yeah. That's exactly what we just did. Dictionary mapping for functions, right? Yeah, so we just made a little switch statement. I am going to use it. Like this. And we might actually not need this anymore. And I also want to know if in Python you can add up pairs. I don't think so. No, you can't. Yeah, I think this is good enough. What bothered me in this piece of code was that I wanted to be very explicit about which direction I'm talking about and which distance, so I prefixed everything with section, but maybe I'm just not good at typing on this keyboard, but it was bothering me that I had to type so much to get to the goal. So maybe next time I'll experiment with a bit shorter method names and no underscores, like I feel like having underscores in there is slowing me down. Another reason is that I'm using a new monitor. It's quite big, and that means that I'm looking a little bit to the side as I type rather than to the front above my keyboard. And because of that, I have a little bit of a misalignment with my hands and screen. And because of that, I continuously mistype stuff. And I feel like if I'm just using my normal screen, the monitor on my MacBook, I don't get that. Oh, that's one of the downsides of having a big screen, I would say. Of course, I could solve that by moving my code to the middle. Maybe that's what I would do next time. But yeah, there's a little bit less space, of course, for a browser. But that is something that could work. Alright, I'm going to leave it at that. We're done. We solved the puzzle. And I'm going to take a little bit of a rest. It's been very early again. I recommend everyone to get good sleeps before doing Advent of Code. It definitely helps. And if you're going to have to wake up early, as I do, it's Belgium here, Advent of Code starts at 6 a.m. Usually when I wake up for the first hour or so, I am not fresh, I'm not focused, and I would definitely not be in the right state of, in the right mental and physical state to do coding. But my tip to you is to do some physical exercise, try some push-ups, burpees, crunches, sit-ups, whatever works for you. Get your body hot, get your blood flowing. Once you do that, you definitely are going to be able to focus. This kind of drowsy feeling you have right after waking up, it will be gone in like 5 or 10 minutes. Very easy. It's something I didn't do before, but for this challenge I really wanted to put the effort into it, and I thought, yeah, what can I do to really be focused early in the morning? And I tried it, and it really works. So even though I had only 5 hours of sleep, I do feel fit. I'm very sure that this will change in a couple of hours. When it's 10 o'clock or afternoon, I will feel sleepy, but at least I did reach the goal of solving the puzzle early and quickly. Right, thanks for watching again. I'll be streaming again tomorrow morning. I'm going to keep doing this as long as I'm able. And of course, it's a lot of fun if you see this and you want to hang out, that you join the chat. We can look at your code. We can look at how you solved it. If there are any bugs in there, we can try to fix them together. Or if you just want a little hint, want to know why do I get the wrong output, even though I think everything I wrote was correct, I might be able to point out something to you that can help you reach that finish line. That's it. Have a great day. See you at Advent of Code Day 4.